All right. And then make this zone. Okay. So we're just going to cover some chapter 15 stuff and then exam is tomorrow. So we'll just start off with 15.1, which is just functions. So as I mentioned in class, you don't have to worry too much about the, graphing them or anything. Really, from this section, the biggest thing you want to be able to do is to evaluate functions, find the intercepts, and just know that if you have a linear function, that the marginal value is the slope of each variable. So we'll quickly talk about all of those. But just starting simple, right? If we want to evaluate a function, so something like this, okay? And if I say like f of 1, 1, this is the x variable, this is the y variable, and actually let me just make it a 2 instead, so that way we can differentiate them. This would be 1 squared plus 2 squared minus 1 plus 8. So make sure that when you're doing that, that you put it in the correct spot, because that's the easiest mistake you can make. Something like this you can mostly do in your head, but it's not the worst thing to show some work. So we get 12. Okay. So any questions on that one? Okay. So from there, if we want to, we could do something where maybe we're given a function like this. Just grab a different one. I mean, they're all kind of the same idea anyway. So something like x squared minus y minus xy plus 7. And, maybe I ask you to plug in a variable. So like a comma 2. Actually, let me use a different letter because sometimes those look the same. C. So wherever there's an x, I'm going to replace it with c. Wherever there's a y, I'm going to replace it with a 2. And then I get c times 2 plus 7. And then you just got to combine like terms. So c squared can't be combined with anything else. Minus 2c, and then negative 2 plus 7 is a positive 5, right? So just, be able to plug in functions or values into functions correctly, right? Because, you're going to have to do that when you're plugging in the critical points or the corner points or the boundary points, so that you can compute, your values that are max or min. But any questions on that? Just want to make sure. All right. So let's talk about intercepts. So like I mentioned in class yesterday, to find any intercept, you just set all of the other variables equal to 0 and then solve for the one that you want, okay? So let's just pull up an example. So let's say f of x comma y equals 32 plus 8x plus 4y, okay? And then I say find x-intercept. So one thing you have to remember is that f of x comma y is equal to z. Like they're interchangeable. So in reality, this is equal to a z. So if I want to find the x-intercept, I set y equal to 0, z equal to 0, and solve. So 0, because that used to be z, 32 plus 8x plus 4 times 0. And so I get 0 equals 32 plus 8x. And then I get negative 32 over here, 8x, x equals negative 4. So that's the x value. And the intercept would be negative 4 comma 0 comma 0, if you wanted to write it as an ordered pair. Okay. Something like that. If I wanted to do the y-intercept, so let's do the y-intercept. you would do x equals 0 and z equals 0. So 0 equals 32 plus 8 times 0 plus 4y. So 0 equals 32 plus 4y. 0 equals, oops, sorry. Negative 32 equals 4y. Y equals negative 4. So you could write that as 0, negative 4. Sorry, wrong value. Should be an 8. Thank you. Negative 8, comma 0. So when you're writing an intercept, essentially whatever the value that you're looking for, everything else is 0. Okay. Are there any questions on that? Just want to make sure. I want to see if I can do this. I can. Okay. Can I move it over? I can. There we go. And then if I wanted to do the z-intercept, I mean, if you're following the pattern, it's the same thing. So set x equal to 0, y equal to 0. So z is equal to 32 plus 0 plus 0. Z is equal to 32. So the z-intercept tends to be the easier one. Okay. Any questions on that? I just want to make sure. So, know how to find the intercept, or, whatever kind of equation it is. All right. So new slide. I will be posting these slides in the video later, right after this. So, but I'll give you guys one more second to finish copying down. So remaining from this section, so 15.1, linear functions. So a linear function is of the form f of x comma y equals ax plus by plus c, like that, where a is the slope of x, b is the slope of y, and then c is the z-intercept. Okay. So if a question says, what is the marginal cost of x, the marginal cost, of x, then they're really just saying, what is the slope of x, right? What is the number in front of it? That's really what they're asking in this part. Okay. So that's what you got to remember. It's just finding the marginal cost. You can do it by taking the derivative because it's also the derivative, but you can also just get away with it by knowing the slope. Okay. So let's see if there's anything else from 15.1. Doesn't really look like it. Any questions from 15.1? Like I said, it's a short one, so we're just going to move on to 15.2. And we're not going to spend too much time on 15.2, which again is partial derivatives. I do already have a video posted of partial derivatives. And then I also did cover them in class yesterday. I mean, I'll do one or two more examples just so we have some. But if you want to practice more of them, just watch the video that's already been posted. Because I want to really just be able to do like 3 good examples of critical points, finding the max and min, Lagrange method, and then an extreme value theorem problem. So I just want to be able to do one of each of those so that you have a video to watch them. Okay. So 15.2, partial derivatives. And since I already practiced just partial derivatives as, just functions, I'm going to do a word problem one so we can have practice on that. So weekly cost of making X bikes and Y tricycles is, so this is from the homework, C of X, Y equals 30,000 plus 60X plus 50Y. Okay. So the question is, compute marginal cost of bikes and tricycles. Okay. So when you're doing a problem like this and you see the word marginal cost, you're thinking derivative, okay? Specifically partial derivative. So in this case, that means you're going to compute CX and CY. Like these are the two things that you want because this will be your marginal cost and for bikes and then your marginal cost for tricycles, okay? So if you take the derivative with respect to X, 30,000 becomes 0, right? So 0 plus 60X becomes 60, and then 50Y becomes 0, so it is 60. So that means for every extra bike that you make, it's going to cost you $60 more. Okay, so for each bike that you make, it'll cost you $60 more. CY is going to be 0 plus 0 plus 50, and that's $50, right? So for every single tricycle that you make extra, so one more, it's going to cost you $50 more. Okay, are there any questions on that? So that's what marginal cost is, right? Now, B is, so what's a follow-up question we could ask to this? Let me see if they have one for us. Nope, that's pretty much it. Okay, so let's do one that's very similar. So let's start a new slide, but let me give you guys a quick second to copy down. So I'm going to do this, a very similar problem, but I'm just going to make the function a little bit more interesting, just because this one simplified too easily. So I want to do one more where it doesn't simplify as easily. But are there any questions? So I think so far we're doing pretty good. Okay, so same type of problem, same bikes and tricycles, but now say your cost is something like, I mean, I'll still use the same. What do you mean an example of one? I'm not sure what you mean by that. So I'm just pulling this from the homework. So 30x plus 20y plus 0.3xy. Okay, so now the equation won't simplify as easily. So the question, it could be something like, what is the marginal cost of making a bike when you make 10 bikes and 11, let's do a nicer number, 20 tricycles. Okay. For this question specifically, there's not really a follow-up to it. I mean, maybe you write it in English, but this one doesn't have a follow-up to it. It's just like, what's the marginal cost? Because it's too simple of a problem, honestly. Now, this one, I could say, what's the marginal cost? And then ask you, okay, what is the marginal cost when you make this many bikes and tricycles? Okay, so marginal cost of making a bike. So if you want in the chat real quick, am I solving for CX or am I solving for CY? So if you're at home, just think about it for a second. Am I solving for CX or CY? We're still using the same problem, X bikes, Y tricycles. So for this one, we want marginal cost of bikes, so we're solving for CX, right? Does that make sense? So the derivative of 24,000 is 0. The derivative of 30x is 30. The derivative of 20y, 0. The derivative of 0.3x times y, so we're doing CX, that means x is going to become 1, and then my number y is just left alone. So then this is equal to 30 plus 0.3y. So what the question is asking now is 10 bikes, 20 tricycles. So what it's asking for is CX of 10 bikes, 20 tricycles, X comma Y, bike, tricycle. Okay. So you're going to do 30 plus 0.3. Now, do I have an X variable? Nope. So Don't need to do anything about that. So I don't have to plug in 10 anywhere, but I do got to plug a 20 in here. And so this says 30 plus 0, not 0, 6, I believe. And so it's $36. Okay, make sure you have units. So for every additional bike that I make at this level, it's going to cost me $36. So each additional bike cost $36. Okay, so that would be the idea. Any questions on that? So the correct units, if you were talking about units, is $36 per bike. That would be the correct units. Okay. So on the exam, just make sure that you're putting units down. If you don't write any units down, you can lose points. And then because this is a rate, okay, so let's review units real quick. So a rate such as like CX or FX is, you know, unit over unit. It's going to have something like dollars per stereo, dollars per whatever, dollars per hour. There's going to be some kind of unit over unit. If it's just like the cost, like if I just wanted to know the cost, that would just be dollars. Okay. Are there any questions on that? Just want to make sure. All right, let's move on. So I'll just write that down, like dollars per hour or dollars per car. You know, you can just keep going forever. Okay. So just looking at the homework, that pretty much covers 15.2. Like I said, if you need to practice more derivative stuff, you can. I have a video for that already, some notes for it already, and then there's plenty of practice for it available. Like if you review the homework ones, I think that's a good stuff. Like that's a good one. Like it's a good set. If you can do all the homework ones, I think you'll be fine. Okay. If you can do all of the homework ones, you will be fine. Any questions? Just want to make sure. Because now we're going to do 15.3, which is like finding max and min and all that stuff. Because I want to make sure that we get a good example of that. All right. So let me open up the homework for 15.3. Here we go. Okay. So 15.3, max and min. Okay. So straight up example, find and classify extrema, or sorry, critical point of f of x comma y equals 1 minus 4x squared minus x minus y squared plus y. Okay. Now remember what I said in class. Make sure you can do the fundamental ones, the ones that are easier, because 50-minute exam, we can only ask you so many questions, right? So if you can do the easier ones, you're much likely to succeed than if you can only do the hard ones, because sometimes the hard ones require tricks. And if you're just focused on the hard ones, you kind of sometimes lose sight of how the fundamentals work. It's kind of an interesting idea. Okay, so step one, find fx and fy. Okay, we're just going to find the first two derivatives. Now, if you want to, you can preemptively find all of the derivatives, but we can do that later. So fundamentals, we're going to find fx and fy. So fx is equal to 0 minus, I bring down the 2 and I get 8x, minus 1 plus 0 plus 0. So luckily, it's a nice one. My fx is negative 8x minus 1. Not too bad. Okay. Doing the same thing for fy, I get 0 minus 0 minus 0 minus 2y plus 1. So fy is equal to negative 2y plus 1. Okay. Are there any questions on that? So this is like best case scenario. And the reason for that is because they don't share any variables. So really, I just got to solve for one and the other, and then we're good to go. Okay. Worst case scenario, you get something like, they both have x and y, or they have squares and stuff like that. So that's where we got to be careful. Okay. So step 2, set fx equal to 0, fy equals to 0, and solve. Okay. Any questions on that? So 0 equals negative 8x minus 1. So if I add the 1 over, I get negative 8x. And so x is equal to negative 1/8. So that's my x value, right? Let me double check the answer to make sure I got the correct sign. If you notice I make a mistake, just let me know. And then 0 equals negative 2y plus 1. Negative 1 equals negative 2y. My pen stopped working right there. Okay, we're good. And so y equals positive 1/2. So that's the critical point. If you can get to this point, you're already halfway there. Okay, you got at least 6 out of 10 at this point. So the next thing we have to do is classify. Okay, now unfortunately, this formula will not be provided, so you do have to memorize it. You really only have to memorize 2 formulas. Okay, you have to memorize this formula, the second derivative rule, and you have to memorize the Lagrangian formula. Okay, so tonight I would just practice remembering the formulas. Okay, so the formula that you have to remember, so step 3, actually, let's write down our critical point. It's negative 1/8, 1/2. This is our critical point. So step 3 is going to be to classify. So D is equal to fxx fyy minus fxy squared. Okay, that's the formula you have to remember. Then you just got to find fxx. So fxx. So let me write down the original ones we had. So fx is equal to negative 8x minus 1. Fy, make sure I got that right. Yep, is negative 2y plus 1. So fxx is equal to negative 8. Fyy is equal to negative 2. And then I need an fxy. So if I take the derivative of this with respect to y, I get 0. Okay. Are there any questions? So D is equal to negative 8 times negative 2 minus 0, which is 16. Okay. So this is where you have to remember the second derivative rule, which says if D is positive and fxx is greater than 0, it is a minimum. If fxx is less than 0, it is a maximum. Okay. Are there any questions on that? So I just want to make sure. Yep. Or am I? I just want to make sure I have it in the correct order, because sometimes I do get them mixed up. So let's see. Positive. Okay, negative. Yeah, no, we're good. Okay. And then if D is just less than 0, this means saddle. Okay. You don't have to worry about the equals 0, because we're not really going to worry about that. Okay. So one way to think about it, if you have a positive fxx, it's a minimum. Like I almost think about it as it's backwards, because I feel like if it's positive, it should be a maximum, but it's just backwards. That's how I kind of remember it for some reason. So D equals 16. fxx is equal to -8. Oops, let me write that correctly. Which is less than 0. So it's a max. So our coordinate was -1/8. Why does it keep doing that? Comma 1/2 is a max. Okay. Are there any questions on that? All right. Now, in the event, okay, you could have a scenario where your partial derivative doesn't work out nicely, like you get a linear function. So maybe you get something like fx equals, I don't know, 3x plus 2y, and fy equals 6x plus 5y, like that. Actually, I'm going to make it easy for myself right now. So let's say you get something like that. Then you would set both of these equal to 0. And then you can use whatever method you want. You can use elimination method. You can use your graphing calculator to find the intersection. You can use substitution method. You can set them equal to each other, whatever you prefer. So I'm going to use elimination because this is equal to 0. This is equal to 0. And actually, sorry. No, yeah, that's fine. And then this is equal to 7y. Okay. And so 7y negative equals 0. So y equals 0. Okay. Turns out in this case, the solution is going to be 0, 0. But that's just how you would do it. You would solve for the equation. Now, if I made one of these numbers, actually, let me do it this way because it'll be much more interesting. Let me make one of these 1. So I do set it equal to 0, but there's like a +2 and a +3. So then I would move those over. So it'd be -2. Actually, let me not skip that step because I might confuse someone. So 0, 0, +2, +3. Okay. And then you're going to move over the number. So you get -2 equals -6x plus 2y. -3 equals 6x plus 5y. Okay. Any questions on that? Just want to make sure. And then you just solve. So add them together. -5 equals 7y. Y equals -5/7. And then you just plug one of these into either equation and solve for the other. Okay. So that's another scenario you could run into. Are there any questions on that? I just want to make sure. So that is a max/min problem. So make sure that you remember this right here, this formula, and you got to remember this right here. Okay. There's not that many things you have to memorize, but that is one of them. Okay, you do have to unfortunately memorize that. Any questions? So the next thing we're going to do is 15.4, which is a Lagrange. Okay. So let me grab one from the homework. Okay. Like I said, you want to be able to do easier ones because, like I said, we can't really ask you to do very long ones. So we'll just stick to the fundamentals and know how to do the simple ones because, you know, that is much more likely to be on an exam, say, versus like a difficult one. Okay. So let's get set up. So I'm pulling this one straight from the homework. So this is question number 1 on the homework. Find max value of f of x comma y equals x times y, subject to x plus 2y equals 76, right? This is number 1 from homework 15.4. So, step number 1. Set constraint equal to 0. Okay. Now, could you do substitution method? You could. But if I ask in the directions to use Lagrangian and you do substitution, you will not receive full credit. Okay. You can earn some credit, but you will not receive full credit for using the incorrect method. And it's not because your answer is wrong. It's just, it's a question of, do you know how, what I'm grading you on is technique of the method provided. So this right here is our constraint. So we're going to set it equal to 0. So x plus 2y minus 76 equals 0. Okay, that's the first thing you want to do, is set the constraint equal to 0. Step 2, plug into Lagrangian. I think I spelled that right. Lagrangian? Or Lagrange equation, not Lagrangian. That's something else. So this is the other equation you really have to memorize. So L of x comma y is equal to f of x comma y minus lambda times g of x comma y. I don't need that parentheses actually. Or your objective minus lambda times constraint, right? Okay, this is like the only other equation you really have to memorize is that one. Any questions? All right. I'm double check because I didn't see anything. Okay, we're good. So L of x comma y is equal to x times y minus lambda times x plus 2y minus 76. Okay. And don't distribute the lambda. I'm telling you right now, it's almost never worth doing that. Any questions? All right. So next slide. So step 3 is to find Lx and Ly, the partial derivatives of the Lagrangian. So let me see if I can copy this. I gotta use my keyboard. I was probably slower than just rewriting it, honestly. Okay, so Lx is equal to, so with respect to x, the x becomes 1 and I'm left with y minus, let me make that an L, not a 2 looking thing, minus lambda times 1 plus 0 minus 0. Okay, so Lx is equal to y minus lambda. Wow, that one's actually not too bad. And then Ly is equal to, well, derivative of xy is going to be x minus lambda, and this is going to be 0 plus 2 minus 0. So Ly is equal to x minus 2 lambda. So those are my two equations. Step 4, set each equal to 0 and isolate lambda. Okay. Now, if the way that I'm writing is too many steps, you can condense steps down. Okay. You don't have to follow exactly the way I'm showing it to you in terms of the number of steps. But this is just my progression. Okay. Does everyone see that? So then lambda equals y. 2 lambda equals x. So lambda equals x over 2. Okay, so those are my two equations. Let me make sure that looks more like a lambda. So step 5 is set equal and pick a variable or isolate a variable. So y is equal to x over 2. And if you left it like this, 100% correct. But personally speaking, I would rather do 2y equals x. And the reason for that is I don't have a fraction. Okay. Any questions? So this equation, I am going to plug into the constraint. Okay. So that is the equation I am going to plug into the constraint. So step number 6. Okay. But is anyone still copying down? Like if you are, I can slow down. I just need to make sure that, you just gotta let me know. All right. So plug in. So I forgot to label it, but I'll call it star. So plug star into constraint. So our constraint was x plus 2y. You can do the minus 76 equals 0. I mean, it doesn't matter which one you pick. When it does this. Let me see. Okay. Sorry, I need to pause this. So if there's like a weird kind of like the way the equation looks change, it's because temporarily glitch in PowerPoint, so I had to reset it and I lost that slide. So if it looks suddenly different out of nowhere, that's why. Okay, so we know from star that 2y is equal to x, right? That's what star gave us. And from that, we just plug it into, this is x, so I'm going to substitute this right here. So 2y plus 2y minus 76 equals 0. 4y minus 76 equals 0. 4y equals 76. Y equals, I'm assuming 19. And then we're going to plug this right here to get x. So 2 times 19 is equal to 38. So this is x right there. Are there any questions on that? I just want to make sure. So our point is 38, 19. Okay. Now, because this problem wanted me to find the maximum, so I'll go back to the directions, find the max value, and there is only one coordinate, we can safely assume that this is the maximum. But if there's more than one coordinate, you would still want to do the D equation and then test it. Now, just so that we can practice it one more time, we're going to classify it. So step 7 is to classify. Okay, actually, I'll write it on the next slide. Just so that we can see that process one more time. You don't have to really do this if you only have one coordinate or critical point. But if you have more than one, you have to test out which one is which. Okay. So D is equal to fxx fyy minus fxy squared. So you're going to use the Lagrangian equation to test it. Okay, so you're going to test it off the Lagrangian. So LXX is equal to, so if I go to LXX, it looks like that would be 0. And then if we do LYY, over here, we also get 0. And then if we do LXY, okay, so LXY, we get, so it looks like we get 1. So then if I plug it in, I get 0 times 0 minus 1 squared. Okay, just want to make sure that's correct. because that is y. And LYX would be 1. And so we get D is equal to -1. And so this means it's a saddle point. Now, here's the interesting part. All we care about is it being the biggest value. So it being a saddle point isn't that big of a deal anyways, okay? So this is okay, just because it's one coordinate. So now we just need to compute F max. So this is okay. So all you have to do is take your coordinate and plug it into the value. So that would be x times y, which is equal to 38 times 19. Whoops, sorry. And if you compute that correctly, it's 768. So on an exam, we would most likely just be like, hey, compute the Lagrangian and then find the maximum or minimum value, right? So you would just find which one it is. Okay. And now if you have more than one point, I mean, you could classify it. I mean, technically, you could also just make a table too. So in reality, I would probably just use the table next time. I think that's actually simpler to do. Just use the table. So.
Excuse me?
Yeah.
Be 722, or am I missing something? 38 times 19.
Did I just write that wrong? Yeah, you said 732?
I got 722 on my calculator.
Okay. I mean, that's probably right.
I was just making sure. Maybe I missed a step. All right, thank you.
Well, oh yeah, I was looking at the wrong answer. I was looking at a different equation, but yeah, no, it is 722. Thank you. Any questions though? Other ones? So that's Lagrangian. Really? Got to remember this equation right here. Just memorize it, write it down 50 times until you just have it written, in your brain. That one, and obviously these two right here, okay? That's really the only things you truly have to memorize. Okay, last thing, extreme value theorem. This is gonna be the last example. And I'm just gonna do the first one from the homework. Like I said, practice the fundamentals. So let me open up the homework problem from number 1. Let's see. Yeah, I'll do number 1. I mean, number 2 is the same exact one we did in class. I think number 1's just a little bit more interesting, but it's also a little bit longer too, but that's okay. We got time. So it says, so the directions are find the extreme values. That's not right. Of z equals f of x comma y equal to 3x squared minus 2xy plus 4y squared minus 6x minus 20y plus 7, right? I don't think we would ask something like this on the exam, okay? At least not this kind of function, but the fact that it's a square box makes it a little bit better, but I think we'd make a smaller function than this, just because this would be way too long, okay? So, I always tell students, when in doubt, take a derivative, because it's kind of the first thing you always want to do. So step 1, find f. So basically the first thing you want to do is find critical points. So find fx and find fy, because you're going to look for the critical points first. Okay, so that's the first thing you want to calculate, is the critical points. So fx is equal to 6x, because 3x squared, minus 2y plus 0 minus 6 plus 0 plus 0. So that's going to be equal to 6x minus 2y minus 6. Oh, this kind of looks like what I was talking about earlier. Okay. Let me see if I can give myself a little bit more space. Oops, did not want to highlight those. Any questions? gonna move that over just a smidge. Okay, and then I'm gonna do Fy equals 0 minus 2x. Correct? Yep. Plus 8y minus 0 minus 20 plus 0. And so Fy is going to be equal to negative 2x plus 8y minus 20. Any questions on that? I just want to make sure. So those are my two partial derivatives. Now I just need to set equal to 0 and solve for x and y. So I'm going to start a new slide. Step 2. Solve. Sorry. Set fx equal to 0 and fy equal to 0 and solve. So we had 0 equals 6x minus 2y minus 6. 0 equals negative 2x plus 8y minus 20. So the first thing I would do is move the numbers over. So 6x minus 2y equals a positive 6. So I added it over and then flipped it. And then I'm going to add this over and flip it as well. You don't have to flip it. This is how I prefer to see it in my brain, but just like that. And then I can multiply either row by a number. So I'm going to multiply the bottom row by 3 and this by 3. And so my new equations become 6x minus 2y equals 6, negative 6x plus 24y equals 60. So going this way. Then I'm going to add them together, cancel out. 22y equals 66, y equals 3. Okay. And then I'm going to take this equation and I'm just going to plug it into either one over there. So plug in. So 6x minus 2 times 3 equals 6. 6x minus 6 equals 6. 6x equals 12. X equals 2. So my critical point is 2, 3. Okay, does everyone see how I got the critical point? Okay. Now on the homework, they're asking you to calculate the z values for all of them. I would wait till the very end to do that, but you can do it as you go. Okay, it's up to you, but I'd wait till the end. So we have found the critical points. The next thing I would do is I would draw the domain, like draw it. I mean, you could draw it in the beginning, but I would draw it after you find the critical point. So we're going to draw domain. It's going to look something like this. So it's a box and they tell me, 0 to 5 and 0 to 6. So, from here to here is 5 and this is 0. And let me pick some other colors. Green, I guess. From here, it's 6 and, still 0. I will draw that 0. And then same thing over here. Draw that way, 5, and then draw this way. So that's our box. And then this corner point over here is 5, 6. 5, 0. 0, 6, and then 0, 0. So if I ask you for the corner points, it's going to be these 4 points right here. Okay. Our critical point is going to be somewhere on the inside, if it is. It could be on the outside. We did do the example in class where it was on the outside. 2, 3. So we're going to go over 2 and then up 3 and right here. So this is our critical point. This is too thick of a line. So let me make it a little bit less, so thinner. So this is our critical point. Okay. Are there any questions? Because the next step is to find the boundary point. So along each line, I need to test it out. So this is the longest part, is you got to find all of these boundary points. Okay. And so what you're going to do is you're going to plug in each of these equations, because this is y equals 0. This is y equals 6. This is x equals 5. This is x equals 0. You're going to plug in all of these equations into the problem or the function. Now, luckily, the equation is the corner point too, in the sense of it's the same number, so you don't have to like be fancy with it. So in the next slide, step 4, we're going to find boundary points. I'm going to do 2 per slide. So we're going to do x equals 0 and x equals 5, right? Because that's what we did, 5. Yep. So you're going to plug f of 0 comma y into the function. So the function right here, 3x squared, you know, I should probably copy this over so that we have it in front of us so we're not forgetting what it is. So let me just copy and paste that over. Copy, paste. Okay, give me a second. I'm going to erase this right here. I'm going to erase this. I'm just wanting to, this is the top center. Right there. So that's our equation. And so x equals 0, x equals 5. We're going to do y on the next slide if we have enough room, hopefully. So f of 0 comma y equals 0 minus 0 plus 4y squared minus 0 minus 20y plus 7. Okay. So this becomes f of y equals 4y squared minus 20y plus 7. Now, at first glance, you might be thinking, man, that's not going to be good. But then you take the derivative. And you get 8y minus 20. You set it equal to 0. And you get 20 equals 8y. So y is equal to 20 divided by 8, which is 2.5, I believe. Let me double check that because I don't remember off the top of my head. 20 divided by 8, 2.5, yep. So my coordinate is 0, comma 2.5. That's my first boundary point right there. Okay. Then I do the same thing. Now the number 5 is going to be a lot uglier. So f of 5 comma y is equal to 3 times 5 squared plus, or I guess minus, I don't know if I'm going to have enough room, minus 2 times 5 times y plus 4y squared minus 6 times 5 minus 20y plus 7. Okay. So for this, you would have to do some algebra to simplify it. So let's see what that would be equal to. So that would be 125. So because no, 75, sorry. Minus 10y plus 4y squared minus 30 minus 20y plus 7. So let me calculate that full number. So 75 minus 30 plus 7 is 52. So 4y squared minus 10y plus 52. And so this is f of y, and then we're going to take the derivative. And again, our derivative works out nicely. And then we set it equal to 0. And so we add the 10 over. And so y is equal to 10 over 8, which I think is 1.25, yeah. 1.25. So my coordinate is 5, comma 1.25. Let me verify that from the homework, but that does sound right. No, they got 3.75. So did I just not add it correctly? Or did I make a mistake? Oh, I see where I made a mistake. Okay. This should be 30y. I didn't see this 20y, so let me make this a 30y. That's my mistake. So that's 30y, 30y, 30. So that's 30. And then 30 divided by 8 is 3.75. So that is the correct value. Does everyone see what mistake I made? I just didn't combine these right here. Yep. Any questions? Oh, good thing I caught it. So another boundary point. And we got to do it for the y values now. Okay. Do you see how time consuming this problem is? So you're thinking to yourself, okay, I get the technique, but it's probably going to be a little bit easier than this because this is taking a lot of time just computing all the derivatives. So y equals 0 and then y equals 6. Okay. So let me copy down the equation one more time for us. I think I tried to paste it here, so let me just paste it. I do. Right there. All right. So y equals 0, y equals 6. So this is going to be f of x comma 0, which is equal to 3x squared minus 0 plus 0 minus 6x minus 0 plus 7. 3x squared minus 6x plus 7. Take the derivative. 6x minus 6. Okay, and then set it equal to 0. 6x equals 6, so x equals 1. So my coordinate is 1 comma 0 right there. Now the one that's ugly is this one with the 6 term, so it's going to be f of 6 comma y. So now I got to figure out what this is. So 6 squared is 36, so 36 times 3 is 108. Minus 2 times 6 times y, which would be a 12, plus, sorry, I put that backwards. Oops, sorry, I'm doing this backwards. Yeah, when you've been doing this for a while, get backwards. So it's going to be 3x squared minus 2x times 6 minus, I guess, plus 4 times 6 squared minus 6x minus 20 times 6 plus 7. So 3x squared minus 12x. So I got to multiply that by 4. 144 minus 6x minus 120 plus 7. So that would be 2431. What's funny is that even if you messed up the constant number, because you take the derivative, it actually works out fine. So even if you had made a mistake on this part, you're actually saved because of the derivative. So 31. Take the derivative. And then set it equal to 0. Okay. You know, when you're taking an exam, generally speaking, when you get nice numbers, that means you're on the right track. You know, they're not going to be super ugly numbers on an exam just because that's just a hassle to grade. So, you know, it's not an absolute rule by any means, but generally speaking, you know, instructors don't want nasty numbers because they're difficult to grade. So if I go back to my picture, I can plot all of these points. So 0, 2.5. So 0, I don't know, somewhere right here, 2.5. And then 5 and 3.75. So somewhere, I don't know, right here, 5 and 3.75. 0 and, sorry, 1 comma 0. Oops, I went the wrong way on this one. Dang it, I hate when I do that. Like difficult to erase it. Yeah, I got it. So 0.25 would be right here. Just don't get your coordinates backwards. This would be 1 comma 0. And then the other one was 3 comma 6. So somewhere up here. Okay. So how many points do I have to test? 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 points. Okay. So at this point, you would just make a table. So step number 5, is make table. And find max and min. Okay. And this is, time consuming, right? So we'll make a table. X comma Y. So you don't have to do it in any order. So 0, 0. I'm going to do the corner points first. 0, 6, 5, 0, and then 5, 6. And then you're just going to plug them into the equation to get the Z value. And so the biggest one is the maximum. The smallest one is the minimum. So if I plug in 0, 0, I get 7. Okay. I will leave it to you to plug it into the equation because it would just take too long for me to do it. If you do 0, 6, you get 31. If you do 5, 0, you get 52. And if you do 5, 6, you get 16. Then I would do the critical point. So that was 2, 3, and we got negative 29. Then I would do the boundary point. So that was 0, 2.5, 1, 0, 3, 6, and then 5, 3.75. Okay, this would be negative 18, 4, 4, and then negative 4.25. So this is the max because it's the biggest one. And this one's the min because it's the smallest. Okay. So then your answers are these two coordinates. And you would say something like F min is equal to negative 29 at 2, 3. F max is equal to 52 at 5, 0. Any questions on the extreme value theorem? Like I said, would you have something, as long as this one? Probably not. Okay. But the fundamentals are all there. So if you can do this problem, you'll be perfectly fine for the exam. Any questions? Because this is going to be where I end it because we have covered everything. Like I said, if you want more practice on partial derivatives, I uploaded a whole video on it. Okay. So any questions? Is there a shorter way of doing it? Not really. I mean, depending on the function, sometimes you can cheat some things, but realistically, no. I mean, I guess the faster way you could do it is when you calculate all of the coordinates, also plug them into the function at the same time. So you can get the Z values immediately. And then at the very end, you just have to look at which one has the biggest Z value. I don't know if that's faster or not, but in terms of this problem, there's really nothing you can do to speed it up. Honestly, like I'm just looking at every step. I mean, it's just how fast you can solve the critical point. But yeah.
Is there any way you can go over one more linear programming problem?
Unfortunately, excuse me a second. I'm just gonna stop recording now.
Or is